Yeah. Okay,
Okay.
doesn't matter. Doesn't matter.
Is that
Okay,
better?
yeah, that's fine. Yeah, that's perfect. Uh, I go to the Middle Ages because there the people were indoctrinated and convinced that the Earth has to be in the center of the universe. And here the planets circle around the center, and these centers circle around the Earth. And with this model, they could forecast and describe the paths of the planets in the sky. And here we can see that a mathematical model that is based on a wrong physical mechanism can provide exact results. They are in accordance with the observations and measurements, but it is wrong. And please, next slide. A mathematical model that is based on a wrong physical mechanism is misleading, leads to wrong conclusions, and prevents advances in physics and technology. Next slide, please. The funny thing for me is that we are in the same situation now again. In the quantum theory, we do not understand the physical mechanisms, and in the theories of relativity, there are there's a wrong physical basis. Okay, next slide, please. And the reason why the theories of relativity are wrong is very, almost ridiculous, because about 1900, Einstein and Lorentz did not know a little detail about the behavior of photons in a mirror at that time. That was discovered later by Richard Feynman. I come back to this point. Next slide, please. But it's hard to believe that the theories of relativity are wrong, because we have many experimental confirmations of the theory. We know the gravitational waves in the meantime, gravitational lenses, which are very important instrument for astronomers. But here already there's a problem, because the depth of the lenses in our next environment are not deep enough. The results of the experiments, of the observations, are not in accordance with the calculations by the general theory of relativity. We also know, thanks to the theory of relativity, that atomic clocks can tick slower or faster, and at radiation therapy, the electrons must be corrected to increased masses, otherwise this instrument wouldn't work, and. And in the accelerators like CERN, the theories are confirmed all the time. And the established physicists, they are bored if somebody criticizes the theories of relativity. And they think it's a waste of time to think about it, because there are so many confirmations. But next slide, please. How do we deal with an experiment that contradicts the theories of relativity? Can you accept it? Or is your faith so deep that you cannot accept it? Next slide, please. I will show you some experiments in which are not in accordance with the theories of relativity. I begin with Refuting. These scientists traveled around the world with atomic clocks on board, and the idea was that these clock times are compared with a clock on the surface of the Earth. Next slide, please. When two frames move away from each other, and A sends a picture of his or her clock to B, then B concludes that the time in A is delayed, and if they move away from each other, there is a time dilation. And even if they move towards to each other, there is a time dilation. And this is due to the fact that the light speed is finite. But it's clear that these clocks in the frames do not tick different. It's only because it takes some time until the information is at the other frame. And this is it's an observation effect. Next slide, please. But now it was a great surprise because the experiment showed that the atomic clocks ticked really slower. And that was unexpected. And even Einstein was astonished. And you see, this has nothing to do with the transmission of the clock time to the observer. There is, I assume, interaction of the atoms of the clock with maybe the gravity field or with the dark matter, I don't know. And the funny thing is, in order to get in accordance with the formula of time dilation, the observer had to be placed in the center of the Earth or over the North Pole. And this is not in accordance with the basic design where the observer is on the surface of the Earth. Okay, next slide, please. Another experiment that contradicts the theory of relativity. Maurice Allais, an economist and Nobel Prize winner, detected during he observed pendulum, the Foucault pendulum at a solar eclipse, that it changed the direction. And this cannot be described neither by Newton nor by Einstein. And my personal idea is that gravity can be nonlinear fielded. And the next experiments confirm this idea. Please, next slide. An astronomer from South Korea observed the behavior, the dynamic behavior of galaxies in a galaxy heap, the Fornax galaxy heap, and he came to the conclusion that it only can be described by the MOND theory. This is a a modified Newtonian theory. And the big advantage of this theory is that no dark matter is necessary to describe the rotation behavior of the outer stars in a galaxy. And this was also observed for white binary stars that are in a great distance from each other. And here, the MOND theory can also be interpreted as nonlinear shielding of gravitation. Next slide, please. The idea of shielding gravity came from Eugene Podkletnov. he detected by chance that over a fast rotating disk, the gravity was lower. And the interesting thing, even in the floor above, they could measure that the gravity was lower. And his first interpretation was that gravity can be shielded. But this was under great discussions, and they tried to find another interpretation. But anyway, I think this is the most, or this is the best interpretation. Next slide, please. The most important, or no, one of the most important experiments which have been ignored completely were the experiments with Ninel Kulagina. She was a Russian soldier who was injured heavily, also on the head. And one time, one evening when she was very angry, a can on a sideboard flew in her direction. And she realized that she caused this effect. And she trained it, she practiced it, and finally she could move small objects without touching them. And she was examined by many scientists. Also the EEG showed high activities. And yeah, they looked if this can be used for military purposes. But one evening, she was surprised by scientists who intended to show that she used a trick, that she cannot do that. And he brought his own experimental set with him and the cameraman. And then, please, next slide, they demonstrated it. And the question is now, how can she do that? She used no thread, no magnetic. This is anyway not possible with these matches. And the scientists were completely confronted with a mystery. They had no explanation for that. And therefore, please, next slide. Next slide, please. Ian, can you please? Doesn't it work?
Hans, I'm sorry to interrupt, but your sound has disimproved. You're breaking up a bit, and you're actually gone silent now.
Okay, go.
We can't hear you at the moment.
Go off the blank button. Maybe it goes further on the arrow at the right.
I don't know if you did anything different, but it started in the last. Everything is frozen.
Oh,
well.
that's great. Maybe you press
you're back. You're
escape.
Back. Okay, I can hear you now.
Yeah.
However, you're breaking up again.
Huh. Can you go press escape and start from the beginning?
I'm only hearing a little of what you said. Did you say press escape?
Yes, press escape and start from the beginning. Or the space bar, or the arrow at the right
You were
to the
breaking
right
up.
side.
I can't really hear what you're saying. I'm not sure if you're giving me instructions or you're just talking to the slide. It's sort of breaking up very badly.
Yes, okay. Okay, thank you. Okay, the physicists at that time, they were confronted with this experiment, and they were very creative. They invented a paragraph and said physics only can accept experiments that can be repeated in other labs. Therefore, these experiments with Ninel Kulagina were dismissed. But think about it. If you can accept that Ninel Kulagina could do that, then we have here an experimental proof that complex electromagnetic processes can either create gravity or what I assume field gravity. And if we look back to Petkov with a rotating disk, this is a rotating system, a periodic system, and the brain can also create periodic processes. Therefore, I assume that time crystals possibly could field gravity. Therefore, I suggest for all who work with time crystals that they should look if they can detect a gravity effect. And if yes, you become billionaire and even more, because this was a huge technical step. Okay, the next, please. The technical transformation of this psychokinetic effect into a technical application you can see here. This UFO you cannot dismiss anymore because and it's no fake. And this can control gravity and it can and inertia, and it can create a very, very cold environment about this object. By this, it can prevent supersonic bang. But this cooling technology is new and would also bring billions of dollars. And as it is not on the market, I assume that it is an alien technology. And next slide, please. If I say alien technology, that means that aliens can be here. And this is rejected by the normal physicists because they are convinced that the light speed is the maximum possible speed. And this is not true, because in the 80s, a German physicist, Günther Mims from the University of Cologne, sent a signal through a tunnel and through the air, and he remarked that the tunnel signal is faster. And he could transfer a symphony of Mozart with a 7-fold light speed. And later on, he toured through the universities with this experiment on the display here and demonstrated it. But nobody could believe him. This experiment shows clearly that light speed can be faster. And the belief or the faith in the theories of relativity is so deep that almost nobody could accept it. And all those of you who work with big computer systems where the transmission velocity is limited by the speed of light, I recommend take a microwave tunnel, then you can transfer information with a tenfold light speed. Okay, next slide, please. Anyway, I tried to find an experiment which can be accepted by the established physicists, and when I saw this drawing of the Michelson-Morley experiment, I saw immediately that this must be wrong. But why? Next slide, please. If a tennis ball hits a board that is tilted by 45 degrees, the tennis ball will be reflected perpendicular. But if the mirror is moving, then the path of the tennis ball will be oblique. Next slide, please. And Einstein, in his famous 1905 publication, was also convinced that the path of the light of the photons from this 45-degree mirror must be slower by c square minus v square, and later on that there must be a time dilation. Next slide, please. I added here the gamma, which is the Lorentz vector, what you know, I think. And in the Michelson-Morley experiment, the time in the y-axis and the x-axis must be the same to save the null result. But we see in the x-axis there is a gamma too much. And Lorentz came to the idea that one should replace L, which is the distance you see here, divided by the gamma. If one does that, then the times are equal and the null result is null all the time. And here we see that Einstein came to the idea that if time and the length of the space is connected by the velocity, then time and space must be connected. They belong together. But if this is not the case, then the space-time idea is wrong. And okay, next slide, please. I came to this idea because I remembered a conclusion of Feynman. He said that photons in a mirror are not reflected. And this is really crazy, because if you look at the mirror, we think that we see reflected photons from us. But these photons are absorbed by the atoms in the glass, and after a short time, which you can see at this bold lines here, after a short time, new photons are emitted. Next slide, please. And new photons, that means that one can interpret such a mirror as a light source. Next slide. Then we remember Einstein's second postulate that says light is propagating independently of the velocity of the light source. And therefore, in my opinion, the photon must behave like in the next slide. Next slide, please. The photons do not get a momentum in the direction of the movement, but they can miss the detector at the bottom of this. Now, the question is, how can I prove this consideration, my idea? Next slide, please. Now we have the same problem as before with the video. Could you try to get the next slide, please?
Hans, I think we're losing.
I cannot hear you.
Bandwidth problem. So
Yeah.
may I go on to the next slide?
Yes, please.
And maybe you can talk about this then. I can't hear you at the moment. It's breaking up.
Okay.
Okay.
Then I remembered that there is the laser, the moon laser ranging project where they measure the distance of the moon from the Earth with the accuracy of millimeters. And fortunately, these data are published. And so we have now the situation in the textbook and the theory of relativity is the light source of, also the mirror on the moon, which is the light source now, emits photon, they get lateral moment, and they arrive with dispersion, of course, on the detector on the Earth in the lower part. Next slide, please. And my assumption is that these photons appear at that location where the detector was 2.55 seconds before. And they can hit the detector, but not in the full size in this situation. But imagine if the blue arrow is up perpendicular to it, then there would be no displacement, because then the moon-Earth axis would be in the same direction as the velocity of this system. And the formula for this displacement is simple. It's v, the velocity times the time, and depends now on the velocity of the Earth-Moon system in the universe. Next slide, please.
You're breaking up a little again, unfortunately. Seems quiet now. I can't hear
you. Can you bring the next slide?
Shall I?
Yes, thank you.
Okay, I think it might be a problem with certain slides. We can hear you now.
Yeah. Okay, fine. When I read the articles with the lunar laser ranging, I was surprised because I saw that only 10% of the expected photons arrive in the detector. And that confirmed my consideration already a little bit. And so I continued, and fortunately, Tom Murphy, the leader of this project, published the mean value of the return rates for some years. The next slide, please. And when I saw that, I was very surprised, because why should the return rates in September be 10 times greater than in May or in January? And why are there such peaks? And this reminds me to a superposition of sinus functions. Therefore, I came to the idea that I add the displacements of the various velocities of the Earth. Next slide, please. And there we have the rotation of the Earth, and the Earth orbits around the Sun. The Sun system moves to the apex. Our galaxy is rotating with a certain velocity. Our galaxy is moving to the atomic galaxy, and the local group is moving to the great attractor. And then I added all these displacements and started at the vernal equinox, and the beta in this formula is the angle of the velocity direction of the Earth in the universe, and alpha is the angle for the months, for the different months. Next slide, please. When I saw this, I was shocked a little bit, but in a positive sense, because it seems to be a very good correlation, but not perfect. And I asked me why, and then I realized that one velocity is missing, and this is the velocity of the great attractor in the universe. Then I was looking for it. I tried to find the right velocity and the right angle by trial and error. Next slide, please. And finally, I got this correlation. And this is really amazing. And if a physicist tells you that he got such a correlation, something must be wrong. But I added, I forgot to say, I entered the sum of these displacements in a Gaussian distribution, and in the same distribution which is also used by the Lunar laser ranging team in order to calculate the dispersion. Anyway, now I see I'm right, but I was afraid that a defender of relativity could disprove my considerations, and this is very easy. One only has to shift this structure by 1 or 2 days, then the correlation would go to under 50% of the zero. So it depends very much on the time when this pattern starts. Anyway, then I analyzed the daily return rates. Next slide, please. And when I saw that, I was shocked. Here, I selected those years where the Earth-Moon axis points in the same or in about the same direction. with a difference of 4 degrees. And this would simplify the calculations, because I only need tangential velocity and the velocity in the component in the north-south pole direction. Anyway, how can you explain this pattern? Why are the return rates so crazy? I think nobody could explain this by weather or by dust or whatever. And I believed not that I can do that with my addition of displacement. Next slide, please. But then I started in January and I was surprised. I had a good match with 2 peaks. Next slide, please. And again, a nice match. Next slide. And here I was overwhelmed. This is unbelievable. And if you look at the peak in the middle, this shape of the peak is extremely sensitive on the least of the smallest changes of any parameter in the sum of this displacement. Next slide, please. So I continued, and I always found very good matches. Next slide, please. Next slide, please. And here, this is the summary. Here one can see that there are fantastic correlations just by adding the displacements, which in great accordance with the experimental found data. And the probability that this could be wrong is smaller than 10 to the power of minus 80. So that's pretty sure. That is the best explanation for this, like random looking return rates, which were measured. Next slide, please. If you look now at the Michelson-Morley experiment, then it's clear in the case when photons are displaced, there is no oblique light path to the upper mirror. But this is perpendicular and independently of the velocity. And therefore, the gamma must be 1. And the time must be 2t, which is 2 times the normal velocity. And L divided by c. Anyway, in the horizontal axis, the length contraction cannot occur because the length contraction would destroy the null result. And in this case, the space do not change. And there is no more connection between that time and the space. And from the Havlik heating experiment, we know that clocks can really tick slower. And if this is the case here, we have again gamma in the y-axis and gamma in the x-axis. But these are additional and not connected with the gamma which was derived from the Pythagoras. Next slide, please. So the photons that emitted from the mirror do not get a momentum in the direction of movement. And it is wrong to derive a time dilation by the Pythagoras theorem. Therefore, the light clock is wrong too, and the light clock is a pedagogic tool to introduce students into the time dilation. At the Michael-Molly experiment, the Lorentz contraction destroys the null result, I explained, and the Lorentz transformation cannot be applied here. Therefore, Einstein's space-time idea is wrong, and gravity must be explained by a different model. And as I mentioned, I assume that gravity can be filtered, and this is a completely different model on which one can work in the future. And it shows also that the control of gravity and cooling technology, as we can see in UFO, is not possible if we stay with the existing theories of relativity. Okay, that is it. Thank you. Next slide. Thank you.
Thank you. Okay, let me see, can I bring it back now? I want to hand back to you, Hans. So first, get rid of that. Then I'll stop sharing. So I can do that directly. See now, how do I stop sharing? Screen sharing was cancelled. Make sure you click share. Yeah, I think I've automatically got it. So, so I take it, for example, you're not seeing my screen now. I have cancelled
it. Yes, that's right. Yeah.
Very good. Well, thank you very much, Hans, for finishing just after the hour, which is quite exceptional, considering that we waited 10 minutes at the beginning. Thank you very much. And you didn't rush anything.
Yeah.
You spoke clearly and slowly. And we only lost your voice once or twice during, I think, some of the video slides. Now, you forgive me because I didn't mention this in detail at the beginning, but I normally scan through the comments which have come in through the social media, Facebook account.
Okay.
And maybe if there are any questions there, we can put them up and get you to address them. We'll only spend a few minutes doing that. But the problem is that I haven't been able to look at those because I had my screen entirely devoted to the slides.
Okay.
So I just look at those very, very quickly, and then we can put maybe questions to you. Most of the time, they're just conversation between people, so we don't have to deal with them. But then we'll bring some people in from the green room to have more of a discussion, and then somewhere. So let me just see. Are there any points there that we want to put directly to you? Okay. Right. We're still just concerned with mechanics of getting the thing working, so we don't have to worry about those. Yeah, okay. Actually, this is something that had occurred to me, but Quest has said, I just read a paper, most of a paper, that shows that the Haffel and Keating experiment was quite fabricated. I think Kelly in particular has looked at the original data which he got from the U.S. office in Washington, D.C., and hadn't been published, actually. But have any views about that? Do you think that the data presented in the 1971 paper can be trusted, Hans?
Well, I only know the original paper, and what does fabricated mean? I don't know. I trust the people that they could read the atomic clock displays correctly.
Yeah, well, you're more noble. You're more trusting, but Alf Kelly. So he says in this paper, which I think Quest is referring to, obtained the original data, and there were a number of disturbing facts. He found that the clocks were drifting relative to calibrated atomic clocks on the Earth. They were moving all over the place, and one clock was so bad that actually it should have been thrown out. There was some error in it, but most of the readings were actually based on that one clock.
Okay.
And then he found that the original results would actually be meaningless. The average, for example, would mean that there was no difference between the East and West.
Indeed.
So they got a result by altering the data. That's what he means by fabricating. They sort of, so Kelly says, he said, well, look, they got this, and they said, oh, this clock was drifting far too much. So let's take the one that wasn't drifting so much and assume it was in that direction. And they actually got the results that they wanted. So he's very skeptical about the whole experiment.
Yeah, okay, I cannot trust that. But I know that these experiments were repeated and they came to the same result. That clocks can really go faster or slower with high velocities, or faster if the gravity is lower.
Certainly, we know that. I mean, we know it by the working of the GPS, that atomic clocks are affected by velocity.
But this has nothing.
And also gravitational potential, but so I'm not saying that that's nonsense. I say that is true. It's been proved experimentally. But if you accept Kelly's results, he says that this particular experiment, H&K, which is frequently discussed, is actually an experiment that should be thrown in the trash can. So he says.
Okay.
Something to discuss. It might come up again. I'm just still scanning this for somebody's shoveling snow out there, which I could be doing. We do have some snow on the ground here, but anyway. Well, again, Quest has raised something of this nature, but perhaps a distinction has to be made between the physical behavior of atomic clocks and a postulated time dilation. Because many, including myself, might say that time dilation doesn't exist, but atomic clocks do run slow, or they dilate, if you like, with increasing speed.
As I explained at the beginning, the time dilation exists if a clock information, let's say a picture of the display, has to be is sent to another frame. Then if you remember these A and B frames, if B gets the picture of the clock display from A, he concludes that this time is delayed. And this is a delay of time. And if these frames move away from each other, this delay is increased. So we have really a time dilation, but this is an observation effect. And the time dilation, which you mentioned, by slower going clocks, this is obviously due to an interaction with the gravity field or dark energy or whatever. I don't know.
So would you have any problem
I don't hear. Yes, I hear you. Yes, now I hear you. Yeah.
Okay. Would you, Hans, have any problem in calling that rather a clock dilation, or a clock retardation, rather than time? Time doesn't change, perhaps.
Yeah, clock time dilation would be the correct expression,
right?
Because a pendulum clock would run differently, like an atomic clock.
Oh, okay.
And I think this is a interaction, in my opinion, of the atoms of the clock with the gravity field or with the dark energy. And this interaction was never considered because the defenders of the relativity, they use this formula without thinking deeper how this clock time dilation comes together.
Okay, just something on the shielding of gravity, which you mentioned.
Yeah.
Do you conceive of the gravitational force in a different way, following your demonstration of its shielding? I mean, do you consider it as particles, gravitons, or do you consider it as a push-pull mechanism, or you can consider it as a wave motion? Have you any provisional idea?
That's a very interesting question, because we have to look for another model. And I am a fan of Fatio de Douillet, who had the idea that gravity can be explained by pushing particles. And he went to Newton, and Newton laughed at him and said, no, gravity is made by God, of course. And that was the whole story of this idea that this pushing particle cannot work, because the Lesage theory, which came out of this idea, was rejected by at least 7 arguments. But if you look at these arguments, they are all wrong, except of one. And this says that these particles must be moved with a high superluminal speed. And this would fit to the observations in the quantum theory. But anyway, one should, in order to understand gravity, far below the quantum world. The quantum world only describes mechanisms and processes in the deep underground, which we should understand first. My suggestion is to regard the elementary particles as huge structures. I assert that every property is based on a structure, and the elementary particles have many, many properties. And therefore, elementary particles must have a very complex structure, and they can pulsate, oscillate, and by the way, one of the most important questions in physics, I would say, is the question, how do particles move? They have no legs, no wings, and no recoil. And the simplest answer to this question would be they are pushed by pushing particles. And the structures can shield all possible forces by structures which can asymmetric or symmetric, and elementary particle can consist of thousands or million asymmetric structures which can change the directions. And this is a completely new world, I would say. And I try to write a paper in the next years. But the problem is, in 3 weeks I'm 88, so I hope that I can get a paper together in the next years.
Well, you're doing very well. Thank you very much. I've completed looking at the general comments. I'm looking at the private ones now. Some of them have been saying that they could hear you perfectly, and actually it was I who was breaking up. Anyway, I hope you can hear both of us now. Jim Keane and Bob Gray have some questions here, and so does some comment made by Jim Morrison and so on. So I might just ask some people if they'd like to come up and talk directly. So in the green room we have Roger Anderson, Dennis Allen. Just as I mentioned Dennis, he put his hand up. So I'm going to bring you up, Danny, now.
Well, you're.
So any point you'd like to?
Hi, Dennis.
Hi, Hans. Ian, your work shows that light travels at different velocities too, doesn't
it? Once more, please.
So what Danny has said is that my work it also shows that the light travels at different speeds, if you like, different velocities. Yes.
Your work is related to Hertz rather than Maxwell Heaviside.
Indeed. And there have been some discussions about that recently. So we could put that point to Hans, if you wish, Denny. That the Lorentz transformations were a bit of an artificial construct because you were working from partial time differentials in the Maxwell equations, which really didn't give the complete picture because you need to use a total derivative, which includes the convective term, which would always be used in sort of like fluid mechanics, for example. And if you do that, because Hertz did this, so we talk about maybe Maxwell-Hertz equations modified to include the total derivative. Well, then you find that the Lorentz transformations are quite unnecessary. Galilean transformations provide the necessary transformation. So I think that's what you're referring to, Danny. Did you understand what we were trying to say? Quite quickly, Hans. We were saying that this business with the Lorentz transformation is just really a quick fix, which is necessary if you're starting from incorrect premises, which are that the simple expression.
Well, as I showed,
or the heavy side.
Yeah, as I showed, the Lorentz transformation cannot be applied, at least to the Michelson-Morley experiment, because there is no length contraction. And now, if we see that the time dilation is derived from the Pythagoras and not by the interaction of atoms with dark matter, dark energy, dark matter doesn't exist, then this Lorentz transformation is wrong. And we have to find another solution for the Maxwell equations.
And in the MMX, I note that you have expressed the vertical return time as, say, 2L over C,
yes.
which is what actually Michelson did first. And he was correct, if you like. They said, no, he shouldn't have. Well, I would perhaps maintain that it is only approximately that without the lateral movement because of ether entrainment. That's the expression I would perhaps use.
Yes.
Yeah. Okay. You probably wouldn't disagree with that. I mean, if it were perfect ether movement of the
I would have some. We know that the vacuum is not empty. There are many ideas: the vacuum energy, the dark energy, and if we assume that is something similar like the ether, then these interactions would provide all these effects that you can measure.
Well, that spurs one other point I had noted here, which perhaps I could bring in because it's relevant to what Denny has raised and we're talking about now. You gave an example where if the microwave light speed could be 10 times C or something in these conditions. Now I'm just wondering, again, I mean, in my system, you can have forces which are, 10 to the 20 times C. There's no problem.
Okay.
Gravitational interaction might or electrostatic fields. But I'm talking about equivalent to compression and rarefaction in an ether, like analogous to sound waves. Well, then you get a relationship between the magnetic permeability and the electric permittivity, the sort of Newtonian speed.
Yeah.
So, and that would come out. So if you have these purely transverse waves, you get C, let's see what we call C, the celerity and speed of light. Longitudinal waves, quite a different matter. Electrostatic interaction, quite a different matter. So I'm just wondering, if these microwaves are going 10 times this value, how is that expressed in terms of, etheric properties?
I have no idea. Because the measurement shows that the signal comes earlier. I have an idea that beginning again with these pushing particles, if elementary particles are pushed by superluminal pushing particles, then the elementary particles have also superluminal speed in the quantum world, but only for a short time. And when they can pulsate, they can possibly change their direction and can go back and forward so that the mean velocity is just that velocity which can be measured. And I assume in the tunnel they cannot pulsate, and therefore they are pushed with full high-speed velocity through the tunnel. This would be my explanation, but this is only, how should I say,
right, it's a quantum mechanical tunneling.
Fantasy. Okay. Yes, but it must be a reason. And by the way, it's not only a light that can be tunneled quicker, but it was measured for electrons as well. They also can tunnel with superluminal speed.
Okay, so Denny, anything else before we just move on?
Well, those spiky graphs that he had, it seemed to, from what he was saying, it sounded to me like this could be Earth-Moon locking, which is the term you introduced.
I in German.
Locking.
Jan, could you repeat it, please? I understand you better.
I didn't understand. Did you say blocking or locking, Earth Moon?
Locking.
Sorry, didn't. Yeah, I thought you did. You're locking. Yeah, locking. Tidal locking. Yeah.
Where the ether is entrained in between the moon and the Earth in certain circumstances.
Yeah.
It seems to me that ties in with what he was saying, but I can't be sure.
Yeah, you ideally, if there were no locking, you would get, and experimentally we verified this, a zero drag on the ether in respect of the Earth rotating, the Earth spinning on its axis.
Okay.
But you don't get absolutely zero because there's a tidal locking. I think this is what Denny is probably referring to.
Yeah.
Okay. Well, unless you disagree with that or anything to add, maybe we can move on, Denny. Thanks very much for that. Thank you, sir.
You're welcome.
Okay.
Thank you.
So there's a couple of interesting points now, but Jim Morrison actually has raised a couple of points, in particular about Daniel Gazzari's paper on lunar laser ranging. So maybe, Jim, I'll bring you up to put those points directly to Hans rather than my. I can't even put them up from the private chat because I don't have the facility. But so you're up now, and you've also raised a point about maybe repetitions of H and K.
Okay. Hi, Jim.
Hi. Can you hear
me?
Sorry
that I'm here
Perfectly,
without picture.
Yeah. Are you familiar with the Daniel Gazzari's paper that he posted on Archive back in 2009, where he analyzed the time of flight of laser pulses sent to the lunar reflectors put on the moon by the astronauts, and found that the rotation of the Earth affected the essentially the response time by up to 200 meters per second. Just wondering if you'd ever seen that paper.
In my analysis, I saw that this rotation has absolutely no influence. It's too small in comparison to the speed of the local group, which contains several galaxies, including our galaxy, to the great attractor. This is about 600 kilometers per second. And so the rotation of the Earth is almost nothing in this analysis. So the interesting thing is that the effects that one can see in the return rates is influenced very much from this high speeds of our Earth in the universe. That means with the galaxy and within the galaxy and so on. But even the orbit around the Earth, around the Sun, is no big contribution to these correlations which I could show.
Yeah, what do you mean by return rates? I missed that.
Okay.
Sorry.
Okay, they sent a laser beam to the mirror on the moon, and this laser means these photons have a special signature. They have a special color, and they have a special time distance. And the mirror sends the photons back to the Earth, and the detector is near to the laser. And as I mentioned, from this mirror, new photons come back from the moon. And there's an interesting story. When there is full moon, the atoms from the mirror on the moon are so busy to emit new photons that they cannot emit all photons which have been sent from the Earth. So there are photons lost, and therefore at full moon there is a lower return rate. But this effect is not so big that it could influence the correlations that I showed.
And you have a paper that discusses this?
Yes, if you look in the Journal of Physical Mathematics, you will find it. You have to enter my name.
Did you post it on ResearchGate? Because I saw you're on that, right?
Yes.
Okay, I'll look there.
Okay.
Very good. Thank you.
Thank you as well.
Thank you, Jim. I've just noticed a question because I'm just corresponding with one or two people here. No, that's the wrong one, actually. Sorry, it's moved on too quickly. It's just a quest again. It's just from an elementary point of view. How does lunar ranging disprove special relativity? I don't necessarily mean that it doesn't. I just don't understand how. So I think your thesis, Hans, has been that lunar ranging has shown that the basic theory behind the MMX or the null result or the very small result has been incorrect. I think that's your thesis, isn't it?
Okay, I try to explain it once more. You remember the tennis ball, the reflection of the tennis ball. When the tennis ball hits a moving mirror, the tennis ball gets a momentum in the direction of moving. And this is an oblique path of the tennis ball. And Einstein and Lorentz believed that photons also get this momentum in the direction of moving. Therefore, the light beam from the 45-degree mirror to the upper mirror is oblique. And from this, the time dilation is derived by the Pythagoras. And the whole theory of relativity is based on this derivation of the time dilation by the Pythagoras. And in the Michelson-Morley experiment, Lorentz came to the conclusion that there must also be a length contraction in order to save the null result. And I showed that the photons that come from the moon have no momentum in the direction of movement. They go straight to this location where the laser sent it or emitted them. And therefore the path in the Michelson, the light path in the Michelson and Morley picture is straight up perpendicular to the laser beam. Anyway, the Pythagoras cannot be used to derive the time dilation. This must be done by interaction of atoms with, I don't know, dark matter or the non-empty vacuum, let's say, non-empty space. And yeah, that's it. It's very easy. And Einstein and Lorentz did not know that the photons do not get a momentum. And therefore, they were sure that the light beam must be oblique from the 45-degree mirror to the upper mirror. And yeah, that's it.
Okay, so actually, basically, you're not saying that
Ian, I don't understand you. You must activate your microphone first.
Is my volume too low or too high?
No, it's okay. But when you start to speak, the mic I cannot hear. It takes about 2 seconds or 3 seconds when I hear you.
Oh, okay. Well, so if you just hold on and I'll try to speak more slowly. It was just a comment, really, Hans. I was just saying that you don't say that Einstein and Lorentz did not take into account a sort of a lateral movement, and that was erroneous. I have heard that said. You say, no, they took it into account, and that is an error.
Yes. They took into account that photons get a momentum, lateral momentum in direction of the speed of light, speed of
Hans,
the body. Yeah.
James Keane has asked about the peaks matching, and he wasn't clear on what data set this was related to. And he was asking, is there a paper on this? Now, I understand there is a paper, which I think I've looked at one of your papers. So,
yes.
Jim, with your permission, I'm bringing you up so you can put these points directly to Hans, or anything else if you wish.
Well, I just noticed that the peaks on 2-day data sets were matching in a rather remarkable way, and was wondering what I wasn't clear on what the 2 data sets actually were, and perhaps that would be clarified if there is a paper on that.
Hi, Jim. Nice to meet you here.
Hello, yes. Nice to see you,
Hans. I did not quite understand your question. Do you know why these peaks are, why the correlation is so excellent?
No, I don't. I was asking basically what the two peaks were, what the data sets are.
Okay.
I'm sure you explained that, but I just didn't catch it.
Okay.
Maybe if there was a paper on that, I could look at that, because that's an extraordinary correlation that you show.
Yeah, exactly. The peaks, what you have seen, these are the return rates of photons from the mirror on the moon. They just count the photons, and as you can see, sometimes they count 900 photons, and the next day, the next month, when the moon is in culmination, they counted only 2 photons or no photons.
So the horizontal axis is the months of the year.
Yes.
Okay.
I did.
And one of the two. What is the other curve? You have 2 curves which are highly correlated.
The other curve, that was my calculation, but just by adding the displacement which occur by the velocity, by the different velocities of the Earth through the universe.
Oh, fantastic. That's amazing. Okay, thank you.
Okay.
And to boot,
that's really an amazing result you have there.
Yeah, exactly.
In your 3-dimensional depiction, one of the axes is the months. Yeah. The other sort of horizontal axis, is that the observations, the number of observations?
Yes, the number of photons that come per day or come per month. Yes.
Okay.
And therefore,
my work in binary mechanics suggests, especially in my analysis of inertial propulsion phenomena, suggests that there might be an absolute direction, not only an absolute frame, but also an absolute direction. And it seems to me your data is suggesting that at least agrees with that idea to some extent.
Well, it's more complex, because I thought that I could compare I could take the displacement from the velocity of the Earth in the direction of the dipole Microsoft background. But then
the CMB background, yes.
Yes, but then I realized that because of these many peaks, various directions are necessary to explain this complex pattern which one can see in the data.
Okay, well, I'll look for your paper on papers on ResearchGate. You seem to be having done some very imaginative work. Thank you for your presentation, Hans.
Okay.
And I think if you Google Hans Deyssenroth, maybe lunar laser ranging, you'll get a couple of other options for his papers.
Yeah.
Okay. So thank you very much, Jim.
Hillary Publishing. Okay.
I've seen a couple of references to your papers, so people might wish to do that. Okay. The time is catching up on us. Let's see. Actually, Bob Gray had a number of questions. He seems to have left. I don't know what they were. Let me just go back and see what they were. Yeah, I know he didn't seem to have technical matters. Okay. Yeah, well, I mean, Jim has come back and he says, how does the velocity of the Earth with respect to the universe affect the intensity of the reflections of lunar laser pulse? But you seem to have shown, Hans, that when you took into account the final omitted velocity, in other words, the one towards the great attractor, I think, it seemed to give all these correlations.
Yes, exactly. Yeah.
Right.
But it does not, excuse me, to answer the question, the velocities do not influence the reflections. But what I would like to show is that the photons do not appear in the detector, which is near to the laser, but that the photons are sent to this place where the detector was 2.55 seconds before. But the reflection is not influenced by the velocities of the Earth and the universe.
Okay, so it does not affect the intensity of the reflections, for example.
Yeah.